In example 4 here, we have the following. Consider the graph of the sinusoidal function y equals 2 sine 3x, or 2 sine 3 theta, sorry. Describe the transformation to transform y equals sine theta to y equals 2 sine 3 theta. So, things that we need to know. That 2 is something and that 3 is something. Well, 2 is always our vertical stretch, 3 is our horizontal stretch, but we have special names on these now. So let's quickly jot down the original transformation names. So we have a vertical stretch by a factor of 2 and a horizontal stretch by a factor of, and if we pull that out, it's going to be the reciprocal 1/3. So vertical stretch, this has a special name, by the way. This is called your amplitude. So I'm going to call it AMP for short, amplitude. And this one down here, horizontal stretch, this is going to be your period, or it's going to play into your period somehow. Let's talk amplitude. So amplitude here is going to be 2, and so that means the highest and the lowest we're going to go on this graph here is about 2 and -2 if you moved it around the origin, or sorry, your x-axis there. So we'll state the period and the amplitude after we sketch this out, and determine the domain range after we sketch this out. So let's sketch out this graph, 2 sine 3 theta. So the way I type that in, we got is 2 sine 3x, and x is going to be theta for us today. Notice that on this graph here though, our x-axis is going up to 360, so we're switching into degrees mode. It looks like it's going to be every 30, 60, 90, so every 30 is what we want for our window setting. So our window setting, let's go between 0 and 360, going up by 30. And on our y-axis, again, I have between 0 and 4 at the top, -4 at the bottom there. So I'm going to go min, -4, max, +4, and it is going up by 1 there. So there we go. Right now, before I hit graph, I need to double check my mode. If my window setting here is in terms of degrees, my mode needs to be also in terms of degrees. So I'm going to switch over to degrees, hit enter on that, and now I'm ready to graph. And there you go. I hit graph, and that's what I get. If I go second graph, I bring up a table of values. And again, this table value is the same thing as before. But because we're going from 0 to 360, we want to change up our table set between 0, going up by 30 degrees there, and table values again. So here we go. At 0 degrees, we're at 0, 30 degrees, we're at 2, 60, we're at 0, 30, or sorry, 90, we're at -2. So it's just going to repeat itself there. So let's jot down a few of these coordinates. So at 0, we're at 0. At 30, we were at 2. 60, we were at 0. And at 90, we're at -2. That pattern is just going to continue if you take a look. So 0, 2, 0, -2, 0, 2, 0, -2. So that pattern is just going to cycle through and repeat itself. So the next one here should be a 0. Then we have our max. Again, 0, min, 0 at 270 max, right beside it 0 minimum, and at 360 0. And right now we're just going to try our best to sketch this graph here, and I'm just going to double color it, and it's going to look something like this. And there we go. I have my graph on the page here. And again, it does match up to the graph that we had on our calculator. So let's go back and finish off B and C. State the period. So the period is one full rotation before it starts repeating itself. So if you started at 0 and you went up and you went down and you're at this 0 here. So if it repeats itself by going in these humps here above the x-axis, that's going to be the same. So then our period there would have been between 0 and 60 degrees. 60 degrees would have been the period, but it doesn't repeat there. It dips down into the negatives and then right back here. So this period is from this starting dot 0, 0 to this dot here at 120 degrees. And again, if you follow this going up, going all the way down, back here, 120 degrees right here. This next one here, 240. Going up, going down, 360. So what's our period? Our period is every 120 degrees we have our graph in full. So our period, so period is going to equal 120 degrees. Okay, and our amplitude, well, now that we have it sketched, from the starting line of 0, 0, we're going up to, down to, that's the same on both. That's going to be our amplitude. Our amplitude here is equal to 2. And again, I could have also used an equation to get to this 2 here. That's the absolute value of our max is 2 minus our min, which is negative 2 there. All of that divided by 2, and of course that's 4 over 2, which is just 2, and that's how we got our amplitude as well. So you have two different ways to do it: either read off of your graph or use the equation. Down here, domain and range. So our domain, as far left as we can go, and as far right as we can go. So our domain is going to be from negative infinity to positive infinity. Our range, how low, how high are we going? The lowest we went, negative 2, highest we went was positive 2. So we're going from negative 2 to positive 2 for our range square brackets because we are including them. In example 5 here, it says consider the graph of the sinusoidal function of y equals 1 half cos 1 half theta. Notice that here on our x-axis we're talking in terms of pi, which is radian, so I want to switch my calculator back to radian mode, and I need to figure out, well, what lines do I have? If pi is right here, I have 3 sections, so this is now going to be 30, 60, 90, which is pi. So again, this is going to be the first one's 30, which is pi over 6, 60, which is pi over 3, 90. Okay, 30, 60, 90 is what we have. Then after that, another 30 is 210, which is 7 pi over 6. 8 pi over 6 is the same thing as saying 4 pi over 3, and I believe that's enough coordinates that I think you're going to get this idea. All we're going to do is graph this on our calculator and see what this one looks like. In this case here we have 1 half, and I'm going to use my fraction function for the 1 half. So I got 1 half cos of 1 half again. And what am I missing? X or theta there. Close bracket, hit graph, and there we go. That's going to be our graph. Oh, we forgot to change our window setting. So our window setting in this example here, again, noticing that we're in terms of radian, so I want to switch it back to radian mode and change up my window setting. So the far left that we're going is 0. The furthest right on this question looks like 3 pi, maybe 4 pi even, so I'm just going to go to 4 pi there. And each one of those squares is worth pi over 6. Lowest highest that we were going on this question, it looks like between 1 and negative 1. So let's set that in. So between negative, let's go negative 1.5 just to give us some space. Positive 1.5 there. Our scale is looking like 0.25 of a scale. And there you have it. That's going to be our curve this time here. Again, you're going to go second graph, bring up a table of values, and pick off some coordinates here. So at 0, you should have had a coordinate at a half. The next one's a bit tricky. You're guessing where negative 0.37 is. So yeah, let's try our best to graph this. So here I just have to double check my table of values, double checking that my window settings start at 0 and I'm going up on a scale of pi over 6. So again, type in your table change as pi over 6. Oops. There we go. And if you pulled up your table values, these are all their coordinates here. And again, you're going to try your best to sketch as many of these as possible. And there we have it. I've just did a quick sketch of my graph here, and hopefully we matched it up. Let's talk about some of these questions here. So, describe the transformations to get from y equals cos theta to y equals 1/2 cos 1/2 theta. So, we definitely have two stretches. So the first stretch, of course, is our vertical stretch on the outside. So we have a vertical stretch. Vertical stretch. And that's by a factor of 1/2. And so let me rewrite that, and ran out of space. So this is a vertical stretch by 1/2. And we have a horizontal stretch by 2, because we're going to reciprocate that there. And again, of course, our vertical stretch is our amplitude, and our horizontal stretch is going to help us with the period. So state your period and amplitude. So period in this case here, what are we doing? Either one, we can read it right off the graph. So one full cycle is between 0 and what ends up being 4 pi. So we have a full cycle of between 0 and 4 pi. Or we can use our equation for period. So period is going to be equal to 2 pi divided by your absolute value of your b value. Okay, and so we're going to type in 2 pi divided by, and our b value was not this 2, this is already pulled out of our equation. Our b value has to be this number right here in our equation. So our b value is 1/2. And if you simplify this is 2 pi divided by 1/2, which is now 4 pi. Again, b value is in our equation. This is not in our equation. This is a statement that if I gave you the statement, you would have had to rewrite it back into an equation to pull out a b value for period. For our amplitude, again, we had an equation, or you just look, well, we went as high as 1/2, went as low as 1/2. Most likely our amplitude is going to be 1/2, but we also have an equation that we can run to double check that. And the equation for amplitude is equal to the absolute value of your maximum value minus off that minimum value in absolute values, all divided by 2. That's basically 1 divided by 2, which is now just equal to 1/2. Our domain and range on this one here, domain as far left as we can go and as far right as we can go, we're going to be everything for a domain. So that's going to be from negative infinity to positive infinity. And our range, the lowest and highest we're going is negative 1/2 as the low end and positive 1/2 at the high end. And there we go. That is example 5. In example 6 here, again, we're given this graph here, and it's asking you find an equation for y equals a sine b theta. So first off, let's take a look for our amplitude. Well, without our equation, we can figure, well, actually we could use an equation because we have a max value here, and that number looks to be at 3. That's your max right there. And you have a minimum value here at -3. That's your minimum value. So you could use your equation to find amplitude. But because we have a visual representation, my amplitude is always going to be the same distance to get to your max and the same distance to get to your minimum. Okay, so my distance here is 3 to get to my max. That distance has to be the exact same to get to your minimum. And of course it is if you count squares, that's also 3. So my amplitude right away is 3. Therefore A is equal to 3. To find our period, well, when does one full cycle occur? It's starting at 0, goes all the way up, goes all the way down, then it goes all the way down again, all the way back up at pi. And then once at pi, we're restarting that process of going up again. So our period is equal to pi. But to figure out our b value, let's find our b value. So again, we had an equation of period equals 2 pi divided by absolute values of b. Okay, and that was our equation. But in this case here, we know our period is pi, so I'm going to sub some things in. So I can say pi is equal to 2 pi over the absolute value of b. let's switch these around. So our b value is equal to 2 pi divided by pi, which is just simply 2. So to write down our equation, we have y equals a, which is 3, sine b, which is 2 theta. And this b, because we already found it, we just write it in. We don't have to reciprocate it or any of that because we truly are using the actual b value. When we write out our statement, when we write out a sentence, that's when you want to reciprocate that. So it's by horizontal stretch by a factor of 1/2. In this last equation here, again, we just want to write an equation in terms of a cos b theta. So again, let's start off with our amplitude. And again, you do have an equation of max minus min divided by 2. So your max here would have been 2 minus min here at negative 2 divided by 2. You would have had an amplitude of 2. And again, you could visually see an amplitude of 2 instead, because this to your x-axis is 2 away, and to your minimum value it has to be that exact same distance away, also 2 away, so therefore our amplitude equals 2. So that also means a equals 2 in this case here. Period. Well, in this case here we're going to be working in terms of degrees. So our period is from where to where? Well, where's our start and finish? Well, my finish looks like it's over here. My start could be potentially right here because we're going from, for cos, top to top or from a bottom to a bottom. We don't see the other bottom, but let's go from top to top. This distance from top to top is my period, and basically I need to figure out, well, how far is that? Well, this is from negative 360 to 0, that's a distance of 360, plus from 0 to 360, that's another distance of 360. In total, our period is equal to 720 degrees. So to find our b value, again, I want to rewrite an equation. So our equation is period equals 2, well, in this case, not 2 pi, it's going to be 360 because we're in terms of degrees over absolute value of b. Again, so then b is now equal to 360 divided by my period. Well, my period was 720. So 360 over 720, well, this is the same thing as saying 1 over 2. And again, that is our b value. So let's write down our final equation. Our final equation here is y equals a, which is 2, cos bracket 1/2, because that's our b value, theta. And there we go. So here, this is our answer that usually would have been accepted, and that definitely works. Another one that most people don't think about is what happens if you wrote it this way. What happens if you wrote y equals negative 2 cos bracket 1/2 theta, and it's not even or. I'm going to take out the word or there. This is our equation. So we had amplitude of 2, b value of 1/2. If I graph that versus this one here, and let's figure out why I want to graph this second one here and not this first one. So let's go to our graph here. So the first graph here was 2 cos 1/2. I can just short form that to 0.5x, by the way. Between negative 360 and positive 360. Let's go up by 30. And our y values are going as high as, let's pick low as negative 3, high of 3, going up by 1 there. Okay, so if I graph this first one, and again, this is what I'm graphing, 2 cos 0.5x, do I match up? Oh no, I got this really funky graph here. What do I need to do? Double check my mode. Switch it over to degrees, hit graph now. So this is what I would have, but this does not match up to the picture here. So what should I do? If I added a negative in front of that 2 there, now we match up, and that negative means we have a reflection. So we needed this. This would have been our answer, and we needed that negative because we have a reflection on the x-axis. And how did we know? Well, we tested this equation here. Something was slightly off, so we just added in a negative, and now we're good. That's the end of our lesson. If you have any questions, please feel free to ask.